Hello everyone. Today we are going to check up the audiometry of the patient using audiometer. So before starting we are discuss about the brief theory of the audiometer. So the human ear having a three main section which consist of outer ear, the middle ear and the inner ear. The sound wave enter the outer ear and travel through the ear canal to the middle ear. The ear canal channel the wave to the eardrum. A thin, sensitive and membrane stretched tightly over the entrance to the middle ear. The wave cause the eardrum to the vibrate. It passes this vibration on the hammer, one of the three tiny bones in the ear. The hammer vibrate, cause the anvil. The small bone touch the hammer to the vibrate. The anvil pass this vibration to the strip up, another small bone which touch the anvil. From the strip up, the vibration pass into the inner ear. The strip up touch the liquid filled stack and the vibration travel into the cochlear, which is shaped likely a shell. Inside the cochlear there are 100 of special cells attached to the nerve fibers which can transmit information to the brain. The brain process that information from the ear and this distinguish between different types of sound. So basically these are the small description how the sound travel in the human ear and that wave how the process by the human eardrum and forward that signal to the brain like a raw data, and that data processed by the brain and provided to a human in a useful information form. So now we are moved to the practical session. So let's start. So this is the audiometer which was used for check up the audiometry of the person. So brand of this device is Urfi and model is Proton 5 SX5. So first of all we are discuss about the push button given on the front panel. So these arrow up and down arrow used for changing the frequency level from 250 Hz to 8 kHz, and second one is these arrow are used for change the level of intensity in dB from -5 dB to 100 dB decibel, and these are used for masking. Masking mean when we are checking the audiometry of left ear and we realize we are listening a some sound in right ear, that time we are giving a masking for stopping the sound on right hand side, because this will create a disturbance for measuring the audiometry of the person. So these navigation buttons are used for changing the mode like this. Now there is a AC is blinking. AC mean air conduction test, and when I press the next arrow it switch to BC. BC means bone conduction test. Okay, and here is the menu button and here is the select. If I want to conduct air conduction test. Then I click on select button. Here we can see next window ask us for set masking. If we change that masking from on to off, then we click on select. Now we didn't need to make any masking, so I am directly press to the select button. Okay, so here is the front panel. Now we are going to frequency tab and change the frequency to a initial stage. So 250 is your initial set frequency, and now we are going to a intensity point and change the intensity range. So minus 10 dB is your lowest value of intensity, and if we are using a masking button, then we giving the masking to a selected ear. Now we can see here is a written as ACL. That means now we are checking the audiometry of left ear, air conduction left. When we are done with the air conduction left, we can press the shift LR button for changing the ear. Now I press the LR button, and here you can see ACR. Now we are going to take the reading of ACR, air conduction of right, and the talk over button which was used for a talk to your instructor, because this test is performed in soundproof cabin where instructor are sitting outside the cabin and patient are sitting in that cable, and in between both of them there is a transparent window. From there they can see each other, and when they need to ask or want to tell something about the test, like comfortness or uncomfortness, so in that situation patient need to take the long press of the talk over button and told whatever he want to told to the instructor. Next is tone selector. Tone selector was used for change the frequency type HZC to HZP, HZW, and again HZC. So last and important is stimulate. When we are set up the range of frequency and the intensity level, after the all setting we need to press the stimulate button. When patient press the stimulate button, in that situation if he heard any sound, then he will press on save button, and that frequency is already saved on the graph. If he didn't listen any sound, then he need to move on next intensity level, like this. We need to simulate the sound at every given frequency with respect to every intensity. If in example, if we having a now set at 0.5 decibel of the intensity, first I am setting on the frequency on 250 hertz and going to stimulate button. If I didn't get any sound, then I am increasing the frequency rate, and again I am creating a sound using a stimulate button, and
again and again. If I didn't listen any sound, I am increasing the frequency level to 8000 hertz. If I didn't get any sound at 8000 hertz, then we start again that procedure with the different intensity rate. In previous reading, we had set up the intensity on 5 decibel. Now we increase the rate of intensity to 5 decibel. The normal range of human ear of listening is 20 hertz to 20 kilohertz. So if we are start from 50 decibel range and the set of initial frequency, so we can easily and in few minutes we can perform the audiometry test. Now I press the stimulate button. On the yellow screen you can see there is a 2 sound bar are shown when I am pressing the stimulate button. If the patient get a sound in right ear, because we are testing on a right ear ACR, air conduction test on right ear, then patient need to save that value using a saving button. After that, if he didn't get any sound, then again he need to increase the frequency level up to 8000 hertz.
So now we are going to discuss about the port given in this device. First port is pat reset mean. This port used for patient response. Second one is your phone RT and phone LT used for connecting your headphone, phone right side and phone left side. Next is your bone. This is used for bone conduction test, and here we connect bone conductor. And this one is used for connecting a mic for a talk over with patient and instructor. Next one is your FFRT and FFLT. FFRT is used for free field right and FFLT is free field left.
So this is the USB lead which is used for connecting our device with PC. Here is your USB port, and this is your bone conduction test handset like this, and this is your headphone device which is used for taking a air conduction test. Most probably we are using a red side for right ear and blue side for left ear. So this is your connector, and here you can see phone right like this, and this is your phone left. Okay, so this is the basic configuration of the audiometry setup or audiometry device. Now you can see I am wearing the headset and connecting that headset with the audiometry, and here is the right hand side which I used for a red one, and here is your blue connector which I used for a left ear. So now I move to the device and seeing the what types of the result are shown when I am going to check up my audiometry in this video. So let's start. So in my PC I am already installed the software of Audiometer, and here I open the software and going to
the new patient and enter here the all detail of the patient. Like this, like a date of birth, after entering the all detail, I'm clicking on the save button, and here you can see in the list of patient your patient was added. So we need to select that patient name and click on the load patient. After clicking on load, we see the new window open. Clicking on session and click on new session. After all setting, we go to move the front panel. In front panel, we click on file and selected the same port which was connected between your audiometer and your PC, and the same interface which is shown in your audiometer has been open in your window. From here you can choose which types of test you want to conduct from your machine. So I'm selecting from my machine using select button. Using select button, I click on AC. So this is your next window. I did not want to set any masking on my ear, so I'm click on the off, and here you can see this is your front panel which is show your ACL and 250 Hertz C. C indicates the continue, and if we choose B, that we are using a pulse, and next one is your 50 dB is your intensity. So we are changing the frequency range for each decibel point from 250 Hertz to 8000 Hertz, from -5 dB to up to 30 or 40 dB. So here you can see I am choosing a maximum range of 800 Hertz for 15 decibel in last value, because human ear is hearing range is 20 dB, so less than 20 dB we didn't hear any sound, so we can increase the value from 20 dB, and here you can see I'm set the range of frequency is 500 Hertz and press this simulate button, and you can see on simulate level there is a small green color line has been filled when I press simulate button. And so this is the final audiograph of my left ear. So first sound I listen on 8000 Hertz frequency or 20 dB. So after taking the audiogram of the left ear, I am clicking on the LR shift. With the help of LR shift, now my audiogram shift to the right ear. So here you can see a red circle which was marked on 20 dB or 4000 Hertz. At that sound or at that intensity or frequency, I listen a small faint sound. So for this I press on save button and mark that value on the graph. After that, I am changing the intensity to 25 dB and continuously changing the frequency from 500 Hz to 1000. Now I am on 1500 Hz, and here you can see 2000 Hz, but still I didn't get any sound when I am pressing a simulate button. And now you can see I am set a frequency range is 3000 Hz on 25 decibel, and here I am listening a sound. So I am again press the save button and mark that value. Same procedure I am follow for marking the another observation in the graph as follow. So this is the final value on 35 intensity level and 250 Hz frequency, where I get a sound and I marked it on my audiogram. So this is the final merged graph of my left or right ear air conduction test. So you can see the red one and red circle indicates the ACR air conduction right, and blue one is shown the left ear conduction test. After that we go to file and choose a print report option. Here you can see written as left right separate or left right merged graph. You can click on left right merge, and here you can see the print command has been opened. If you have a printer, then you can directly print the graph. Otherwise you need to select a save as PDF Microsoft print to PDF option, then go to the save button. And now this dialog box asking you to give a name to the file, and here you can write the name of the patient for the indication the file. After that click on save button, and now your file has been saved. For checking the file we are going to the desktop, and here you can see the PDF has been created. Double click on that PDF and you can see this is your output report has been saved in PDF form. So finally we are done with the auditory system checkup using audiometer completed in this session. So thank you for watching.
Please don't forget to like and subscribe my